Good afternoon, students. Today, before exam, I will check. Yes, good afternoon. So I will just don't leave the session because I will check when all the attendance will be given, that whether the phone number of all of you provided here is correct or not. So please confirm me that. Okay, 70. Today is like 12th, right? So the phone number you provided in the, in the last class, in the 5th of, 5th of January, uh, are all, is that phone number is yours? If I try to contact all of you during the exam, then I can contact you or I will be contacting your parents. Please confirm that. Am I audible?
Ma'am, it is our
Yes,
Yes,
ma'am.
personal
ma'am.
phone number.
It's our
They
personal
will
phone number,
directly
ma'am.
contact to us.
Okay, that's why I want to know now because there are some students probably they have provided their parents' number. If someone is like that, please WhatsApp me in my number and correct your phone number. In the chemical section, some people did that. Okay.
Ma'am, in 5th January, I was absent, so please check my mobile number.
क्या?
इन 5th जनवरी को मैं एब्सेंट था, क्लास नहीं कर पाया था ड्यू टू इंटरनेट
अच्छा,
कनेक्शन।
ठीक है, कोई
तो
इशू नहीं है। तो आज जो डाल रहे हैं वो तुम्हारा रिस्पॉन्स है ना खुद का?
हाँ हाँ, यस यस मैम।
ठीक है, तो अपना रिस्पॉन्स डालो, ठीक है, तब मुझे समझ में आएगा ना। I only received like 25 responses. Anyway, we can start. Uh, there are almost 65 students, but I only received 30 responses. So plus, first complete giving the attendance. Then I will check and then I will be taking the class because today's portion left is like very small part. We will be finishing within half an hour. So there is a small suggestion for exam that try to remember all the mathematical part what we did earlier and we will be doing today, because you will get probably questions from mathematical part. And I think already Nariman madam or Pentas had discussed about the exam, right?
Not much, ma'am.
No, actually they informed you how many questions will be there.
No, ma'am.
No मैम।
Oh, as far I came to know, that is like there will be 15 questions, 15 marks, and your time will be given like 40 minutes. And there will be questions, on mathematical calculations. So please keep your, calculator and everything with you, because you have to calculate some of the hardness and alkalinity and other even if other Painter sir or Nariman madam what taught you, that if that contains any mathematical calculation, try to remember those parts. Okay, so I will be teaching today alkalinity. So let me first share the slide. Just a minute. Okay. So, unit 1, alkalinity. $57 attendance.
मैम आई हैव एन डाउट।
Yes.
मैम कल हम लोग को एक लिस्ट आया था एमएमई में, अब ना 114 स्टूडेंट ही हैं सिर्फ। हेलो।
Yes, actually your voice is
यस मैम।
breaking,
यस मैम, अभी प्रेजेंट में हम लोग के मेटलर्जी ब्रांच में सिर्फ 111 स्टूडेंट है। मैम हम
अच्छा।
लोग पहले जो अटेंडेंस हम लोग 114 के अकॉर्डिंग देते थे, तो अभी मैम हम लोग का रोल नंबर चेंज हो गया, तो हम लोग कैसे अटेंडेंस दें?
देखो, तुम्हारे पास वो एक्सेल शीट है ना, जिसमें
यस मैम।
पुराना, हाँ, जिसमें पुराना नंबर वगैरह है ना, तो
यस
आज
मैम।
का जो अटेंडेंस डाला है, आज उसके हिसाब से डालो, ठीक है। फिर मेरे पास अभी जैसे मेटलर्जी का आ गया, मगर
ओके।
कंप्यूटर और आईटी का रोल नंबर का लिस्ट मेरे पास अभी तक नहीं आया, ठीक है।
यस
और तुम
मैम।
लोगों का क्लास एग्जॉस्ट रहेगा अप टू प्रोबेबली 22 ऑफ जनवरी, राइट। सो
ओके
क्या
मैम।
होगा, मुझे लगता है आफ्टर 22 ऑफ जनवरी एवरी टीचर्स और द फैकल्टी मेंबर्स विल गेट द अपडेटेड रोल नंबर ऑफ द ऑल द स्टूडेंट्स, ठीक है।
ओके मैम। मैम प्रीवियस के
उसके
अकॉर्डिंग दे
बाद,
दे रहा हूँ।
हाँ, आज तुम लोग इस एक्सेल के हिसाब से दे दो, ठीक है।
ओके मैम।
और उसके बाद, हाँ, उसके बाद जो होगा, मैं वो तुम्हारा जो रोल नंबर अभी अपडेटेड हुआ है उसके बाद से वो देना, ठीक है। मगर सेक्शन मेंशन करना, जैसे के, एफ,
यस मैम।
एल, व्हाटएवर, या बिकॉज के, एफ और आई व्हाटएवर है सेक्शन, तुम लोग उसके बाद भी रोल नंबर के बाद भी मेंशन करना। नहीं तो जैसे वो हम लोग क्या हो रहा है एक्चुअली, नंबर तुम लोगों का भी जो 101 है, या जो 100, जैसे तुम्हारा 101 है, राइट। तो तुम्हारा
यस
शायद
मैम।
चेंज हो, या तो क्या होगा, तुम्हारा चेंज हो
100
गया
हो गया
95, हाँ 100 हुआ है,
है। यस
या
मैम।
95,
यस
96
मैम।
ऐसा होगा। ज्यादा चेंज नहीं होता है, तो उसके
यस मैम।
आसपास ही रहेगा। तो बात क्या है कि हम लोगों को समझ में नहीं आया है ना, और ये तो एक कंबाइंड सेक्शन है, तो
ओके मैम।
सेक्शन, हाँ, सेक्शन इन्फॉर्म, आई मीन लिखना पड़ेगा, ठीक है। तो चलो आज का क्लास हम लोग स्टार्ट करते हैं।
गॉट
फिर
इट।
देखते हैं कि, हाँ, फिर देखते हैं कि सबका अटेंडेंस मिला कि नहीं, ओनली 68 responses. I
Ma'am,
need to get,
I did
yes.
it with new roll number.
Okay, no issue. I will search your name. You mentioned your stream, na?
Yes, ma'am.
Okay, so I will check. Is it possible for you to repeat? I mean, to give attendance one more time?
Ma'am, I'll try.
या देखो तो ये रिस्पॉन्स लिमिट टू 1 रिस्पॉन्स है कि नहीं। अगर लिमिट टू 1 रिस्पॉन्स नहीं है सेटिंग्स में, तो तुम फिर एक बार कोशिश करो, ठीक है। एक बार कोशिश करके देखो, अगर हो सकता है तो। 1 मिनट रुक जाओ, मैं लिमिट टू 1 रिस्पॉन्स अगर है तो
मैम नहीं हो
उसको,
रहा है।
नहीं हो रहा है ना।
यस
मैम
मैम।
वहाँ
अच्छा,
पे ऑप्शन आ रहा है एडिट
अभी हो
योर
जाएगा,
रिस्पॉन्स।
अभी हो जाएगा। मैं लिमिट टू रिस्पॉन्स ब्लॉक कर दिया, ठीक है। तो
यस मैम, हो रहा था अभी।
हाँ हाँ, हो
Yes,
जाएगा,
ma'am.
हो
Edit
जाएगा।
response is available.
ओ।
हाँ यार, तो जिन लोगों ने अपडेटेड रोल नंबर दिया है वो लोग फिर से वो पुराना रोल नंबर दे के कर दो, तो मेरे लिए आज आसान होगा। तो नेक्स्ट डे से मैं अपडेट कर लूंगी, ठीक है। अच्छा चलो, आज पहले क्लास का ये पार्ट खत्म कर ले, क्योंकि दिस विल बी इंक्लूडेड इन योर एग्जाम, एंड यू प्रोबेबली मे गेट, आई मीन, यू नो, questions from this mathematical part, okay. And I will be uploading this part today. So previously all the part I have taught, you have got, you have received the text, right? है ना, सबको तो स्लाइड मिल गया ना प्रीवियसली, सब सेक्शन, सब वो बॉयलर ट्रबल या उसका।
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
हाँ, बॉयलर ट्रबल भी अच्छी तरह से पढ़ना, जैसे कॉस्टिक एम्ब्रिटलमेंट कौन से सॉल्ट के लिए होता है, और स्लाजेस किसको बोलते हैं, व्हाट इज, व्हाट आर द salts causing temporary hardness which can cause permanent hardness, ये सब छोटा मोटा क्वेश्चन याद रखना, ठीक है। ये सब अच्छा चलो, मैं अभी अल्कालिनिटी को स्टार्ट कर रही हूँ। अच्छा, तो बेसिकली व्हाट इज अल्कालिनिटी, so let me make it full screen. Okay, so what is alkalinity? Alkalinity is like the ability of water to neutralize the acid. And and now, so alkalinity can be present in the water by presence of different anions like hydroxide, carbonate, bicarbonate, all these anions. Now, alkalinity can be of two types. Number one, caustic alkalinity, which can be caused by hydroxide and carbonate ion only, carbonate ion, and another is bicarbonate alkalinity. That bicarbonate alkalinity will be due to the presence of the bicarbonate anion. Now, the common method for determining the alkalinity of a water sample is like the titration. Like if there is alkalinity, like the hydroxide, carbonate, or bicarbonate present in the water sample, then there is an indicator is added, and then in a volumetric flask, and then from a pipette, not from a pipette, from a burette, like a standard acid solution is added to neutralize the alkalinity of the water. Now this process is called, I think you all know, right, what this is called? This process is called titration, right? Am I audible?
Yes.
Yes, ma'am.
Yeah, so you don't know this is called titration? You haven't heard about the word titration?
Yeah, I heard about titration.
Ma'am.
Okay, so anyway, this is called titration, and when we are calculating the alkalinity on the basis of a standard solution and on the basis of a concentration or the normality of a standard solution, and in that case the volume is considered. Like let us consider 50 ml of water sample containing different type of alkaline material was taken in a conical flask. Now I am adding a standard acid solution which was prepared by calculation, and the concentration is known, and I am adding that from a burette. Okay, so and from the burette I can see that how much what volume of acid was utilized for neutralizing the alkaline material present in the water. So that volume is marked, and depending on the concentration and that volume, and there is a very common equation. Depending on that, the alkalinity of the solution is calculated. Now this is the pH scale. I think you all know about pH. pH is a scale which measures the percentage of H plus and H minus ion in the water. So pH scale is basically from 0 to 14. From 0 to 7 is 0 to 6 is like acidic pH, and then 8 to 14 is like alkaline pH, and 7 is the neutral. So let's go into the next slide. Now the let us consider that I have taken an alkaline solution in a conical flask, and I am adding acid over that. So how will I know that when the titration will be done, that is the concentration of the amount of alkali present in the solution will be consumed by the acid given? How do I know that? For that reason, an indicator is given. Now, what is an indicator? An indicator is basically organic molecule which shows to different color in acidic and basic solution. Okay, so there are lots of indicator. Normally here we will be talking about phenolphthalein and methyl orange, and beside that there are other indicators also, like as far I remember, methyl red, bromocresol green. These all are indicators. And there are some specification about indicator is like that all the indicators doesn't act in the same pH range. Okay, like phenolphthalein I'm talking about. Phenolphthalein is an indicator which is mainly used for strong acid and strong base titration. Okay, so and phenolphthalein indicator is active in more than 7 pH. While methyl orange, what we will be talking about later, they are active in like weak base and strong acid. Just consider weak base and just focus on the word that what I'm talking about, weak base and strong acid. So if the acid is strong, right, so then in the solution there will be excess of acid, so the pH of the final solution might have acidity more, and in that case the methyl orange will be active. So methyl orange indicator is used in those titration where the pH is less than 7. So now let us consider like a solution which contains this all type of hydroxide, carbonate and bicarbonate. Now hydroxide ion when reacts with water, it will be forming H2O. Similarly, bicarbonate will be forming in presence of hydrogen, will be forming carbon dioxide and H2O. But carbonate anion, they have a two-step process of neutralization. First, in the carbonate ion will be consuming one equivalent of proton and will be forming bicarbonate, and that bicarbonate will be again consuming one H plus ion for the formation of H2 and carbon dioxide. So basically, if there is a if there is a process, what is what we are when we are going to titrate carbonate ion, then the total volume of carbonate anion will not be detected by phenolphthalein indicator. Okay, because when the carbonate will be consuming 1 H plus ion, then it will be forming bicarbonate, and at that point the efficiency of the phenolphthalein indicator will be finished. Now the second part of the reaction, when that carbonate will be consuming 1 H plus ion and will be forming carbon dioxide and H2O, then for that reaction the methyl orange indicator is required. So this is the beauty of carbonate anion. But if the solution contains only bicarbonate anion, then if we add phenolphthalein indicator, then there will be no color change. For that reason, for that solution, first we will add phenolphthalein. We will see that, oh, there is no color change. So we will add another indicator like methyl orange. Okay, then we can see there is a color change or there is a generation of color. So it indicates like there is a minimum alkalinity, and then that will be titrated. Now again, if in a solution when we add hydroxide which contains hydroxide, and then we add phenolphthalein, then the color will be visible. So the fact is that now, depending on these titration values or the amount of volume of the acid is added, that can be measured by the word endpoint. Like, what is the endpoint? The endpoint is the point where the equivalent amount of acid can neutralize the equivalent amount of base. Okay, so that point, like, let us consider a solution contains some percentage of alkali, and then when we are adding continuously acid, then the acids are consumed by the alkali. Then at a certain point, all the alkali present in that solution will be neutralized by the acid, and on one drop of addition of excess acid, that there will be a change in the color of the indicator, because the indicator at that one drop will be changing its color from acidic to basic form, from basic to acidic form, and that point is called the end point. So now phenolphthalein end point is reached when the hydroxide and half of the carbonate ion is titrated, and methyl orange indicator indicates the total alkalinity of the sample. So methyl orange can identify the hydroxide, carbonate and bicarbonate. So all the three alkalis. But for the higher pH, it is always better to use phenolphthalein, and for the lower pH, it is better to use the methyl orange because of the accuracy of the indicator. Now, let me see what it is written. Okay, so the phenolphthalein can identify hydroxide and half of the carbonate, and methyl orange can identify all the anions. And the alkalinity of the total alkalinity of the solution can be termed as M, and because that is detected by the methyl orange indicator, and the alkalinity caused by the hydroxide and the half of the bicarbonate is termed as a phenolphthalein endpoint, that is the P. Now, there are few anions which can be present, which can cause alkalinity, like hydroxide, carbonate, and bicarbonate. These are the basic, the initials. I mean, if they are present in the single molecule, then these are the main anions. Now, beside that, there is a possibility of presence of alkalinity by the mixture of the anions, like hydroxide and carbonate. Okay, and another option is like carbonate and bicarbonate. So there is one more option left, like I am talking about hydroxide and carbonate and carbonate and bicarbonate. Now you can ask that why hydroxide and bicarbonate will not be together, because they are also causing the alkalinity. The fact is that when there will be hydroxide and bicarbonate, then as the hydroxide is stronger base than bicarbonate, it will be abstracting one proton from it, and will form the carbonate and water. So that will be again generating the carbonate anion in the solution. So that's why it is considered like hydroxide and carbonate. So let's now go to the, okay, so this is, I was talking about the titration, right? So this is called the pipette, and this is, just a minute, okay. So basically we are talking about this. This is the example of a titration. So where this is a measuring cylinder. My slide is visible, right?
Yes, ma'am, it is visible.
Okay, so this is a measuring cylinder. You see that measuring cylinder is a cylinder, glass cylinder, where the volume is marked. Now this is called a pipette. This is a standard volumetric flask. This is water bottle, and this is a pipette bulb, or this is actually a graduated pipette. This is called a normal pipette, what we used to work during our college days. And like here, there is a mark which actually tells that if the volume is up to this, then that is a 20 ml. And this is called graduated pipette because you can see here the volume is marked. And now this is a conical flask, this is a beaker, this is a burette. Now what we will do, like let me share, I will show that later. Okay. Now let's.
Ma'am, which one is called graduated pipette?
This one, which contains the the rubber cap on it.
Okay.
That is called the graduated
dropper,
pipette.
like.
Yeah, no, it's not dropper. A dropper is like a very small. It's like it will maximum contain like 5 ml. A graduated pipette can contain up to like 20 ml, first of all. And second of all is like that graduated pipette is like a better quality of glass, like made up of Borosil. And the volume here is perfectly, standardized. Okay. So if it is said that like 1 ml, then it will be 1 ml. It is not will be like 0.05 ml because they are calibrated. The volume is calibrated on this, these marked glass instruments. Glass apparatus. For that reason, they are very costly, very much costly. These glass apparatus, and they are only prepared by Borosil. We are also using local made things, but they are not so much. Not so much. The volume is not so much calibrated. So. These things are, this is called the graduated pipette, and this is a conical flask, this is beaker, and this is burette. So in the burette, normally what is done, the acid is kept here. The acid is, you cannot keep base here. The acid is kept in the burette, and the alkalinity present in the water is taken in the conical flask. Then a drop of indicator is added. If the solution is basic or the alkaline, then the color of the indicator will be, the indicator, we can see the color of the indicator, and then by slow addition of, I mean drop by drop, or the addition should be in very controlled hand, the addition of acid, there will be a certain color change like a magic. So at a certain point you will see an abrupt color change, and that is the point where the equivalent equivalence point, or you can say the end point of the titration is achieved. And another thing is that when you are doing the titration, then what is happening, you are taking the alkaline solution in the flask, so you need to add acid drop by drop, and you need to continuously stir it. Otherwise there will be local pH will be changed, and the rest of the part will not be changed. So if you don't shake it continuously, then maybe you will be adding more acid at the end product. Okay, so it is like these things are need to be mentioned. I will show you a video after that also, after this lecture. So let me first finish this. And this is the methyl orange indicator. I just told earlier that the indicators are like the organic molecules. So you see, this is a azo. This is basically an azo compound. This is the basic form. So when you, that's why it is the you see SO3 minus. Now in the acidic form, there will be a protonation here, and there the structure will be converting from benzenoid to quinonoid, and the color will be changed from yellow to red. This is the change in the color for the methyl orange indicator. And another indicator is phenolphthalein indicator. Now what is phenolphthalein? It is very easy to remember. Now this is a phthalic acid. A phthalic acid is an acid which contains 2 carboxylic acid at the ortho position, and 1 carbon here just provide 2 phenols. So phenolphthalein, you see, phthalic acid and a conjugation of phenol. So 2 phenols are added with 1 carbon of phthalic acid. And now I think you will remember this thing very easily. Now this is the phenolphthalein indicator in the acidic form. Now, and it is the colorless. Now, so in the basic form, it will be pink. So when you will be adding the acid from outside, I mean the burette, so in one point you will see the color change from pink to colorless. So that is the point where the end point is achieved. And in the acidic, I mean, when there will be excess base, at that time what happens? The one of the proton is abstracted from this OH, and then from again the benzenoid to quinonoid structure, and this is the basic form. And in the acid form, this will be protonated, and then this OH minus will attack here, and then this will be again forming the benzenoid structure. Okay, so this is, you see, so this is the example of, you see, this is the basic color, the color of the phenolphthalein indicator at the basic condensed basic environment. It is the acidic, and for the methyl orange, the left one is the acidic, the basic, and the right one is like the acidic. So the change in the color is visible. Now this is the procedure what I just told earlier. I'm not going to show these things. I will be just showing a video of this titration, and then we will be directly going to the, you know, the
So today's experiment is to determine the percentage composition of NaOH.
Just a minute, I will be showing the titration, and then directly I will be going to the let me show, 1 minute. Okay, so you will see here how the titration is done and the color is changed, although this is a different video.
2 grams resolving per liter solution. This is your mixture solution which contains NaOH and NaCl. This is 0.01 HCl solution. This is pipette, 20 ml pipette, and this is burette. So first you have to fill the burette with 0.01 HCl solution up to the mark,
You people can also see this video available in the YouTube. Okay, just see here. So here actually what sir is doing, sir added little bit more acid and then finally standardizing the volume of the the volume of the acid up to like 50 ml in the burette. Now he is taking 20 ml of the alkaline solution in the conical flask, and there is so first he is rinsing the solution, rinsing the pipette with the then he see there will be a mark, and up to that mark he will be adding the he will be adding the so 20 ml of that mark is at 20 in the pipette. There is a mark which indicates the 20 ml volume, and he has taken that, and after that he is adding a drop of phenolphthalein indicator. So in the basic condition, the color of the phenolphthalein indicator is like pink. We can see that, right? Now he is adding acid to this solution, and see he is continuously stirring. And in the equivalence point, the color of the indicator will be changed to colorless. So just wait and see that. See? Okay. So this is done. I am closing this. Okay. So you have seen how the titration is done. So okay. So from that you will get to know what is the volume of the the acid is added. Now from that volume of the acid added, you can calculate the strength of the solution. Now that we will be talking that in the next slide. Now see, this is a chart, and this formula you need to remember. Now see here, it is that there is a when you are going to perform a titration, if there is no change on the addition of phenolphthalein indicator, then it indicates like there is no presence of carbonate and hydroxide ion. Now if on addition of methyl orange there is a color change, then only the bicarbonate is present, because the alkalinity there is only because of the bicarbonate anion which is detected by methyl orange. Now if on addition of methyl orange or bicarbonate, we can see a change in color, and the volume required for methyl orange titration and phenolphthalein titration is the same, then there is only hydroxide is present. Okay. Now there are also two other options, and for those two other options, the formula of the concentration of the hydroxide, carbonate and bicarbonate is mentioned. Now this formula and chart you need to remember for the calculation. Okay, now this is I'm directly going to a directly I'm going to an example which is required for your exam. Like let us consider that, like let me show just a minute. Okay, like okay, just see here. So in the at the time of titration, I told like when we are going to perform a titration, then we know, like sir was also talking, that we know the concentration of the standard acid solution, right? So here just see, the normality of acid solution is known, the volume of the acid solution we can see from the graduated burette, right? And we know the amount of the water, alkaline water sample, because we have taken that from a pipette like 20 ml. So what is unknown parameter? Only one is the unknown parameter, that is N2. That is the strength or the normality of the water. So there is an equation which is for which by which this all the strength. This is a very common equation, and those who are studying chemistry, they need it up to like PhD, postdoc every time. So this is a very standard equation. It actually says the concentration into volume of the standard solution is equal to the concentration and the volume of the unknown solution. Now in these four parameter, the standard for the concentration and the volume of the standard solution is known, because we have prepared a standard solution by a standard method. So the concentration of that solution is known, and the volume can be we are getting from the burette. And now for the unknown solution, the concentration is unknown, but the volume we added in a measured amount. So only one unknown parameter is like that, N2. So by getting the N2, the strength of the unknown solution can be achieved. Now the fact is that, like, every time when we are measuring the alkalinity, like the hardness also, it is also measured in the equivalent weight of calcium carbonate, because it is easy to use calcium carbonate as a molecular weight of calcium carbonate is 100. So when we will be talking about the alkalinity of a sample, we will be talking about the equivalent weight of calcium carbonate, and by that we can convert that into ppm, like milligram per ml. So that is the the way to measure or to report the alkalinity of a sample. So if we from this equation we will be knowing the normality of that water, because the strength of the acid was given in the normality. So the normality of water multiplied by equivalent weight of calcium carbonate, and for the like this is for like gram per ml, and if this is mg per ml, so from that mg per ml we will be getting the strength of the alkaline solution in ppm or mg per ml. Okay, now let us consider, I am directly going to a mathematical part. Okay, so I am going to, if you have any copies with me, then it will be easier for all of you, because I don't have also the green board. So can you please write, then maybe we can do one mathematics together, and then it will be easier for all of you to understand. Can you please start writing with a pen and the copy? Do you have that, any of you?
Yes, ma'am.
Yeah, so please start, take a copy, and I am giving you a small mathematics, like 100 ml of a raw water sample we have taken. Okay, any one of you is writing, or no one is writing? If anyone is writing, then also fine.
Writing.
Yeah, okay. So just consider that you have taken 100 ml of water sample. So and the acid what we have provided you is like N/50 HCl. Okay, so just remember the volume of water is 100 ml. The strength of acid what I have given is N/50. Okay, now the phenolphthalein end point is 12.4 ml. Okay, let me share a slide. You can see my slide.
Yes, ma'am.
Yes, ma'am.
Yes,
Okay,
ma'am.
so I'm moving my slide. Is that visible?
Yes, ma'am.
Okay. So here I have given that the phenolphthalein endpoint is 12.4. Okay, so write P equal to 12.4. Now in the next line write M equal to 15.2 ml. Okay. Now tell me which equation we should applicable for this this from here. Just tell me which situation is applicable for this this sample.
Could you again say about M?
Yeah, M is like 15.2 and P is like 12.4. Now these are the possible combinations. Now tell me which of among these five, which one is applicable for this unknown sample?
Last one, ma'am.
Last one, ma'am.
Why last one?
Second
Fourth one.
Because M is greater than P.
Fourth one.
Fourth
Second
one.
last.
I don't know fourth, last and everything. Just tell me which one. P is greater than half of M by M, or P is less than half?
P is
P
greater
is greater than half
less
of
than-
M.
Yes, because if it is P is 12.4 and half of M is like 7.6, right?
Yes, ma'am.
Yes,
7.6. So P is greater than half by M. So for this solution, there is presence of hydroxide and also carbonate. So bicarbonate in this solution is not present. So the alkalinity in this solution is due to hydroxide and carbonate. Now tell me the volume of acid required to neutralize only the hydroxide ion, putting all the values in 2p minus m. Tell me this one.
10.2, 6.9, 9.6.
9.6.
9.6, ma'am.
It is if 9.6 is all for all of you, you got that?
Yes,
Or
ma'am.
any of you
9.6.
got
Yes, ma'am.
different?
9.6.
Is
Yes,
it
ma'am.
9.6?
Yes.
All of you got the same?
Yes, ma'am.
Yes, ma'am.
Okay, now what is for carbonate?
5.6.
5.6.
Yes, ma'am.
Everybody got the same?
Yes, ma'am.
Okay, very good. Now the fact is that now let me show the another slide. Okay. Something just a minute. Something is written here. Actually, I have read from the books, na, so I haven't looked at the slide properly. Anyway, so now in your copy, write for 1 mole of acid. 1 mole of acid is equivalent to 1 mole equivalent of calcium carbonate. Write in your copy this one. Okay. So 1000 ml 1 normal acid requires 50 gram of 50 gram equivalent of calcium carbonate, right? I will show you. I have a book here. Do you understand, or I will show you my book? Wait. See.
Ma'am, 1 mole of acid is equivalent to what?
1 mole of acid is required. 1 mole of acid is equivalent to 1 mole of alkalinity. Now we are expressing alkalinity in the gram equivalent of calcium carbonate, right? So 1 mole of for 1 mole of acid, that is equivalent to 1 mole of calcium carbonate, right?
Yes, ma'am.
Is it okay for understand, or I should go for? It is okay for all of you?
Yes, ma'am.
No, I only hear 2 yes, ma'am. What about the rest of the people?
Madam, how the table came?
Look for presence of 1 mole of acid, for neutralization of 1 mole of acid, 1 mole of base is required, right?
Yes, ma'am.
Yes, because the number of molecules is same. Now alkalinity is expressed in the unit of calcium carbonate. Okay, so for 1 mole of acid, 1 mole of calcium carbonate should be present, because if we consider calcium carbonate as an alkaline material. Okay.
Yes, ma'am.
Yes, ma'am. Yes.
Yes, ma'am.
Yes, ma'am.
Yes, I think you understand, because the calcium carbonate here is like alkalinity. So the now for 1 gram equivalent of acid, 1 gram equivalent of calcium carbonate is needed. So it is said actually for just a minute. 1000 here it is not written actually in the book also. Anyway, so so for like 1000 ml 1 normal acid, 50 gram equivalent of calcium carbonate is required, because 50 is like the equivalent weight of calcium carbonate. Write that. Right? 1000 ml 1 normal acid is equal to 50 gram of calcium carbonate. Write this one. Okay.
Ma'am, acid will be monobasic.
Monobasic, dibasic, now we are not talking about that. We are just converting everything to the to the calcium carbonate. Okay. We will be converting alkalinity to the calcium carbonate indicator. Now we are not talking about this basicity and the strength of acid. Now the strength of acid will be calculated depending on the other issues. No, don't consider that. First finish this thing. Right, 1000 ml 1 normal acid is equal to 50 gram of calcium carbonate. Whether you have written or not, tell me that first. You have written that or not?
Yes, ma'am.
Written.
Yes, ma'am.
In the next line, you write 1 ml 1 normal acid is equal to
50 by
50
1000.
divided by 1000
1000.
gram of calcium carbonate. So it means 50 milligram of calcium carbonate, right? 1 ml 1 normal acid is equals to 50 milligram of calcium carbonate. Okay, done? Up to this part done?
Yes.
ma'am.
Yes, ma'am.
Okay, now 9.6 ml in by 50 acid is equal to,
Once again, repeat it. 9.6 ml.
in by 50. In by 50 was the acid strength and 9.6 ml was the acid required for neutralizing the hydroxide only. So what will be that? 9.6 into 50 into 1 by 50.
Into 9.6.
Yes, this mg of calcium carbonate. So what is that? 9.50 by 50 will be done. So will be so just there will be 9.6 mg of calcium carbonate, right?
Yes, ma'am.
Yes, ma'am.
Okay, so this amount of calcium, this amount of equivalent calcium carbonate, it's present in the 100 ml of water,
Yes, ma'am.
right? Because your total volume initial was 100 ml.
Yes, ma'am.
Now consider for one unit of water, how much it will be?
Ma'am, it was 1000 ml or 100
No,
ml.
Actually, it was 1000.
No, not 1000 ml. I have given like 100 ml, right? I told 1000
You
ml.
were
Ma'am, you said
speak-
1000 ml of
Center.
1000 ml 1 m.
Okay, okay. If it is 1000 ml, then consider what it is. Then consider it is like 9.6 divided by 1000.
All right, ma'am.
Okay.
Yes, ma'am.
Now for 1 liter of water. So for 1 liter of water was your standard what I have given. Okay. So in that part you are getting 9.6. Okay, so for 1 liter of standard, like if we want to now convert into 1 liter, then what will be happening? 9.6 divided by 1000 multiplied by 1000, right?
Yes, ma'am.
Yes, ma'am.
So in your solution, you will be having 9.6 mg of calcium carbonate in 1 liter of water.
Yes, ma'am.
Yes, so 9.6 milligram per ml is equivalent to 9.6 ppm, because the parts per million is mg per ml,
Ha, ma'am.
Yes, ma'am.
right? Yes, so mg per ml. So the alkalinity or the hardness, whatever alkalinity present in the water because of hydroxide is 9.6. Okay.
Yes.
Now tell me what is the alkalinity present in that sample of water because of carbonate. Now tell me that in ppm.
Ma'am,
Should I
please
give
go
you
over.
how
Ma'am, please
much?
go over the process once again.
Yes, I will tell again.
Yes, ma'am.
Yes, ma'am.
Okay, so 1000 ml 1 normal acid is equals to 50 gram of calcium carbonate, right?
Yes, ma'am.
So 1 ml 1 normal acid is equals to 50 milligram, because 50 gram will be divided by 1000. So 1 ml 1 normal acid is equivalent to 50 gram equivalent of calcium carbonate, right? For carbonate anion, the volume of the acid required was 5.6 ml and the strength was N by 50. Okay, so 5.6.
Ma'am, 5.6. Where is 5.6?
What about the other answer of the others?
You told 9.6.
11.2. 11.2.
No. 5 point.
No, ma'am, it's 5.
The final answer.
Final answer. How can be 11.2? Final answer will be the addition of. No, don't go to final. First, finish this one. Don't go to final. So, what is the amount of bicarbonate anion present in the solution? Look, I am telling once again. 1 ml.
Ma'am, you're talking.
Sorry.
Ma'am, you're talking about carbonate ion.
Yes, I'm
Isn't
talking
it?
about carbonate ion. Yes, the 1 ml. Just a minute. This.
We have 1000 ml 1 normality acid equals to 50 gram of calcium carbonate in equivalence.
Yes.
And
Now
if you
1
divide
ml.
it
1
by
ml.
50 gram of the calcium carbonate.
Exactly. 50
If you
gram
take
of
1
calcium carbonate.
If we divide both side 100, we have 1 ml 1 normal acid equals to 50 milligram equivalence of calcium carbonate.
Yes.
So your question is, what if we take 5.6 ml of N by 50 normality acid? How much milligrams of calcium carbonate will be required?
Yes.
So, ma'am, wait.
But finally, I get 9.6.
Ma'am, it's 5.6
calcium
gram
carbonate.
of calcium carbonate.
Yes, 5.6 is the answer. Now I am telling those who have got different answers. For them, I am telling once again. It's like for 1000 for 1 ml 1 normal of acid, you are getting 50 gram equivalent of calcium carbonate. Now for 5.6 ml of 1 by
5.6 milligrams of calcium carbonate.
exactly. So for those who didn't got 5.6 ml of N by 50 calcium carbonate, you are getting 50 of the 50 into 5.6 into 1 by 50 gram of calcium carbonate. So this
Yes,
50 and this 50
cancels,
goes.
5.6.
So yes, so 5.6 mg of calcium carbonate is present. Not calcium. Yeah, calcium carbonate equivalent is present. Bicarbonate. Okay. So the amount of the bicarbonate present in the not bicarbonate, sorry. So the amount of the carbonate present in the solution is 5.6 milligram.
Yes, ma'am.
Okay. Or if we convert that now into ppm, that will be, because it is present in the 1000 ml of water. So what is the ppm? 5.6
5.6 ppm.
Yes, 5.6 ppm of hardness or the alkalinity because of the bicarbonate.
Carbonate ion.
Carbonate ion. Now what is the total alkalinity? The total alkalinity will be hydroxide plus carbonate. So for hydroxide, what we got, it was 9.6, and now for the carbonate we are getting 5.6. So total is 9.6 plus 5.6.
15.2.
15.2, right?
Yes, ma'am.
So everybody's answer is 15.2.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Any queries?
Ma'am, go over the hydroxide calculation for 9.6 once more. Ma'am, we had the same data. We'll start with the 1000 ml of 1N acid, which is equivalent to, for hot hydroxide we take with salt.
No, actually, when we have started the reaction, it was like 1000 ml of water, and we have titrated with N by 50 of sulfuric acid, and the phenolphthalein endpoint was 12.4. Okay,
yes,
and the methyl orange endpoint was 15.2. And for this equation, we have employed the equation P is greater than half by M. From there, we got the concentration of hydroxide can be calculated 2 into phenolphthalein endpoint minus
minus 15.2.
Yeah, minus M. Okay,
that would be 9.8.
Yeah, 9.6, right?
9.8.
9.8. Then it is 9.8. Maybe I calculated wrong.
9.8 for hydroxide.
Okay. Anyway, the thing is near about 15.
Yes,
Okay. Maybe I calculated wrong when I did the. I calculated 9.6.
Ma'am, so the similar pattern, if you're calculating for hydroxide, we can calculate for carbonate too.
Yes, from the this was we calculated for hydroxide. Now the second one is like for carbonate, it will be 2 in the bracket m minus p. So m is like here 15.2 minus 12.4.
That is 5.4.
Okay, so that is 2.8 multiplied by 2.
2.7
That is equals to 5.6.
Yes, ma'am, 5.6. Okay.
Yes, and so from as the 9.6 is very easy, and 50, and I have given already n by 50, so all these 50 cancels. So basically directly from here, from 9.6 ppm for is like hydroxide, and 9.8 ppm, right?
Yes, ma'am.
9.8 ppm for hydroxide and 5.6.
9.8, 5.4 आ रहा है मैम, बट ठीक है, और टोटल आंसर इज 15.2.
हाँ
Total
ठीक
answer
है,
is
whatever मैंने कैलकुलेट रॉन्ग किया.
टोटल आंसर इज 15.2.
हाँ
So
तो
this
मैंने
is
क्या किया ना,
divided.
मैंने दोनों ही 9.6 लिखा, एक लिखा 9.6, एक लिखा
मैम
5.6.
पहला 9.6 ही है.
पहला 9.8
ठीक है, वो छोड़ो.
टेबल से 9.8 आ रहा है.
अच्छा ठीक है, अभी तुम लोग और एक एग्जाम वो देखो. अभी ये आंसर तो सबका एक ही आया, एमसीक्यू क्वेश्चन रहेगा, जो भी करो आंसर एक ही होगा. एनीवे, तो देखो अभी सेकंड क्वेश्चन में जाओ. सेकंड और एक मैथमेटिक्स हम लोग करते हैं.
4 बजे एग्जाम शुरू हो रहा है मैम मैथ्स का.
मैम हमारा मॉक टेस्ट है.
अच्छा ठीक है, और एक मैथ्स कर लो. आज ही लास्ट क्लास है. ठीक है, और इसमें अभी तुम्हारा इसके बाद तो कोई क्लास नहीं है ना.
4 बजे से मैथमेटिक्स का
अभी. अच्छा ठीक है. ओके ठीक है चलो ठीक है. बेस्ट ऑफ लक फॉर द एग्जाम. अगर तुम ये जो मैथमेटिक्स है ये लोग तुम करते रहे ना, ठीक है. ये तुम लोग हाँ बताओ.
Can you post some problems so that we can practice?
I am just sending that in the WhatsApp. Okay. मैं ये WhatsApp में डाल रही हूँ. मैंने जो किया था, मैं सिर्फ प्रॉब्लम डाल रही हूँ, ठीक है. और तुम लोग आंसर मुझे WhatsApp आंसर कर लेना, ठीक है.
Ma'am, can you post some sample question paper of chemistry, MCQ1, ma'am?
देखो मेरे पास तो कुछ आइडिया नहीं है. मैं तो अभी बोला ना, इसका क्वेश्चन मैं नहीं कर रही हूँ, मैं नारिमन मैडम कर रहे हैं, ठीक है. तो सिर्फ मुझे
a sample question paper, ma'am, so that we can practice. It's a
no idea. I just can tell you, I think because like I am just telling you, because there will be mathematics, because in the environmental science classes we are giving like 30 questions in 40 minutes, because there is no mathematical calculations. But for you people, we are providing like 15 questions for 40 minutes. So I think there will be mathematical calculation of hardness and this alkalinity. So you need to do all these things properly. Okay. So I will be sending few questions. Do that answer and tell me. Okay. So maybe I will write that in a Google form and share in the the class, Google Classroom. Okay. So anyway, I'm closing because you have a class right now. Okay. Best of luck for your all exam.
Thank you, ma'am.
Okay.
Thank you, ma'am.
Yes.
Thank you, ma'am.
Thank you, ma'am.
Okay.
Thank you, ma'am.
Okay.